Hey, hi. So today we are going to discuss about the component coupling. So in this figure, as you can see, this is one component and one component. So as previously we have discussed about component cohesion, right? So you should wonder what is the difference between coupling and cohesion. So what cohesion talks about, it talks about a single component, how inside like these classes or something, how interconnected they are inside a single component. Okay, and couplings talks about the connectivity between two or more than two components, like interdependency between components. Okay. So to start with component coupling, we are going to first talk about the acyclic dependency principle, that it says that there should be no cyclic dependency present between the component. So before that, before starting to talk about that, author has given a I would say very better example that we can start off is that is called morning after syndrome. So what it says, so it is talking in the author is talking in the context that no there is no component presently, and everyone is working in a single repo, single package, or you can say single file at more granular level. So what's happening in morning after syndrome? It is saying, the author is saying that one day you worked on something, right, on night, you worked late at a night, let's suppose 10 p.m., and you made some of changes in your local, right, and you came into morning, let's suppose 10 a.m., right, and you came into morning and you try to merge your changes, but what happened? The conflict occurs, you are not able to merge it. So what is the happened here? So somebody, it seems somebody work later than you on previous night, let's suppose 11 or 12 p.m., and he made some changes which is overlapping with your changes, and he merged the changes first in morning. Now your changes, you are getting conflict. So this is called a simple example of morning after syndrome. So if multiple people are working in same project, like more than 8 to 10 member team, then this the like probability of happening this will increase, right? The propensity of happening morning after syndrome will increase drastically, and it is a very what unpleasant experience to the developers. So the solution to this is first came the weekly build solution, that what it says, that we are going to each developer, right, in start of week, right, on Monday to, let's suppose, Thursday, each developer is going to work on their changes privately, right, and on Friday they are all going to merge, build the package, or build the service, whatever you can say, so that you can on Friday you are allocating whole day to solving the merge conflict and integrating with a new dependency, right? But if you extrapolate this process, right, once your project become large and more complex, right, the more tendency of happening merge conflict will going to increase, and it even the time bandwidth to resolve this also increase, right, with time it is going to increase. So in to like then again to work on build, you need one extra days, so you are going to start including Thursday too. So you are making changes Monday till Thursday, for Monday till Wednesday, on Thursday and Friday you are working on build. But sooner this will also fail, you have to include Wednesday, and this will process will keep going. Now you have to come up with the bi-weekly build system, where one week you are working on the changes, and next week you are building those changes. So it's clearly, it's very evident that this process is not scalable, and with time you will lose the early feedback process. Like when you are releasing more fastly, you are getting early feedback and you are working on the changes. Now you cannot deliver new changes within window of one week, or you can say your time window will going to increase. So that is the wrong with if you are working in a single package or single file, all developer are working. So this solution, now come up to the solution. By the way, the bi-weekly build solution was uh, what it was like invented or proposed by telecom industry. Like this idea was picked by telecom industry, like they are using this process, which is not useful from for your point of view. Now, so to resolve this problem, what you have to do? So it is saying, the author is saying that you will divide your application, right. Now your application is a single monolithic kind of thing. Now you divided your application in a component part, right. And I'm not going to discuss about what is better, monolithic or micro architecture. It is a separate debate, but I'm like in this context, you are going to divide your application into separate component, which each team or developer can own, that he is going to work on this component, and this guy is working on this component, and you have to come up with some release process, right, where each component you are releasing, and it now it depend upon this. Let's suppose, for example, there are four components in the system, and C uses D and B, right. Now this is like maintained by different one, and this is maintained by different team. They are releasing it on a weekly basis, right, and D also. Now as a C developer, I have a like freedom to whether to consume the latest version or not. It should be depend on me, and I will work on my pace. So this is how you are solving what you are solving the normal issue of dependency. Like of you are giving freedom to the developer, and you are mitigating the morning after syndrome. Now the conflict probability of happening conflict is reduced tremendously compared to previous approach. So now, but with whenever in you and every in this is like a generic statement I'm going to say, that whenever you try to create a new solution, right, whenever you come up with a new solution, it will also bring new problem with it, right. Why? Because according to me, according to my philosophy, the number of problems in the world will remain constant, right. So if you solve existing problems, it will bring some new problem to make this number constant. That is like separate again out of context, but yeah. So this new solution of making component, it is still is like there is one problem with it, which is dependency. So now which will occur in a cyclic dependency. Yeah. So this is the application that we segregated, divided into components. This is main component view, and these are the dependency graph. So the arrow giving from authorizer to interactor, saying that authorizer is depending on interactor, right. And let's suppose you want to build the presenter component, then you have to build the interactor component, and interactor is depend on entity doesn't depend on anything, so you have to build only three components, and you can build it, test it, deploy it separately. That's what benefit you are seeing, getting from a component distribution. right? And it should be so this graph is called directed acyclic graph. Acyclic is that it is mentioning that there is no cyclic, and directed means that you are giving the direction whenever you are going from one component to in which direction you are going. Suppose there is a two nodes in a graph, and I draw a arrow, right? So it is also called a acyclic graph. But now if I give a arrow, direction of arrow, it will be going to called directed acyclic graph. Now I am aware of the direction too. So this is how. So it will definitely going to solve your morning after syndrome problem, and it will give more freedom to the developers to paste up their development testability process. And yeah, it's like the more you develop fast the feature, and the more early you will get feedback, that's how your system will evolve more. Right now, let's suppose what will happen if this system has a cycle. Cycle is suppose in authorizer there is some permission class, and your entities want to use that permission class. Now entities have to depend on authorizer, and luckily we have that image also. So this entity is dependent on authorizer. Now suppose you want to release the database, right? Latest version of database. Now this component should be compatible with the entities, right? Now you build the entities. Now entities should be compatible with the authorizer component, and authorizer will component with interactor, and interactor should be compatible with entities. So I hope you are seeing the cycle here, and you are seeing the trouble also here. So now I know it's not impossible to solve, but now this whole thing, let me use my pencil here. Now this whole thing became again a single component, because now each team has to work to release same time and make their component compatible with each other, right? So that is the problem with the cycle in your component dependency graph. So to solve this, now you get the problem, right? And now you get the problem. Let's talk about the solution. So definitely we have to break the solution cycle. That is the brute force approach. Now there are two ways to break the cycle that I will explain in your separate copy. Right, yeah. So now if you see that entities is depending on authorizer, and let's suppose in authorizer there is some permission class, and entity there is some user class. User is want to use something for permission. That's how the dependency got created. So first way is dependency inversion principle. What it says to inverse the dependency, like you don't want to make entities use of dependency. So what you will do, you will create an interface, permission interface here, right? Interface, let's mark it as I, and now user will extend this interface, user class will extend this interface and implement whatever he want to implement, like permission methods, right? And now in authorizer you are going to implement permission, right? Permission. Now permission is going to implement this interface. So now the dependency got inverted. Now authorizer is depending on the entities which we want in the first place. So if I will show you again this is the explanation. If I show you again the graph, now this dependency will entities, and it will break the cycle, and it will like save us to again becoming a larger components coupled together. So we resolve the coupling. So the other way to break the cycle is you create one new component. This is entities and this is authorizer, and you create a new component, something with permission which encapsulate the permission capability, right? And these two component is going to depend on this permission, right? So there are two ways to resolve this dependency, and definitely there is a code duplication, because you guys have to implement same method here. Earlier, if you are using the permission method from authorizer component, now you have to copy the same code in user class while extending the permission entities. But still it's manageable. You will not in software development, in software architecture, this is the thumb rule, that you will not get everything right. You have to software architecture and development is lots of about trade-off that you are making with the evolving nature of software. You have to make lots of judgment later. That's why it is called soft. That is why the soft word is used in software. Otherwise it would have been called hardware which is strict. So the jitter is saying that if you add a new component in the dependency graph, so it may happen that with a new evolving feature, and when you're incorporating new changes into your whole application, it may happen that this kind of cycle may occur time to time. And whenever you are considering second approach, like creating a new component, it will jitter means small movement in the architecture component diagram, like some subtle movement, right? So it is jittering, and new component is evolving with time to time. So you doesn't want that, right? But again, as I told you earlier, that it's the nature of a software to evolve, right? And you have to make certain decisions with trade-offs. So you have to make dependent decision whether to go with the first approach by dependency inversion principle, like create an interface or create a new component. So you will get that idea when you have more data about it, the requirement and about the dependency. So that is runtime decision. But yeah, that's it for first part of component cohesion. We are going to discuss more in coming up videos.